So good morning. My name is Damien Owens. I'm the Registrar with Engineers Ireland, and I have the pleasure of welcoming you here today and hosting this third BIM session from CITA. I've been involved with CITA for a number of years, mostly in the area of product development and trying to identify new areas where CITA can better serve its members. And one of the areas that was identified was the whole building information modelling space. So it was decided then to put together a series of BIM lectures, of which this is the third. And this wouldn't happen without support from a number of very generous sponsors, including Enterprise Ireland, Autodesk, Bentley, Buildsoft, and the list there on screen. There's also the involvement of iStructD, Engineers Ireland, and the ACI. And just to let you know, they've organised a joint BIM workshop on April 16th. Clyde Road, so you can put that in your diaries. And also these events wouldn't happen without the excellent support team and dedication of the CITA office of Suzanne Purcell, Barbara Fox-Mills, and of course Alan Hoare, who you know well. Just to recap, this is the third in the series of lectures. The previous two lectures in January and February we had fairly high-profile speakers from overseas, and today is no exception. In January, the title of the session was called Setting Aligned Policies for Use in BIM. And we were fortunate enough to have David Phillip, the head of the BIM implementation from the Cabinet Office in London, for quite a good presentation. Last month, the topic was Developing a National Building Materials and Product Library, and we had Drew Wiggett. And just to remind ourselves of what that event was like, we have a brief video. We should have it there, so just 2 minutes.
Just to expand on the introduction a bit, a bit more background about myself. I'm an architectural technician, so as John says, I've been very much at the thick end of project delivery over the last 15 or 17 years. I'm associated with Ryder Architecture, but I'm actually currently in the process of moving over to be employed by the MBS. The typical ones are they will always have a common description, and we've got URL links to the website, maintained issue dates and descriptions and references. So if you're using intelligent tagging, your tags will point at these locations. It's version control, so again, you can load these elements into your model. You can see what version it is. You can check the website to see if it's the most current version, and the website will tell you what the updates are and the differences are.
The question is, the benefits of that library. We can say, well, obviously yes, but we really were thinking more, in a sense, as a template that people in manufacturing, environments can use to initiate the creation of objects. That they're then flexible to be changed in any practice. And that would be very, very helpful to set conventions in relation to object IDs, object names, layering standards, and object categories. Because we believe that on this table that no library will be fully inclusive, and it will be very, very strict in its use that could potentially limit the creativity at the design stage on any project.
So today we continue with the theme of the social and cultural impacts of process change management required for BIM implementation. And I suppose one of the biggest misconceptions among executives and CXOs is that BIM is just a piece of software. In reality, it's much more than that. It's a driver and a facilitator for changing processes across the entire sector. And really what we want to do is understand how we move from the concept where BIM is just a software or a toy to something that is much more meaningful and will deliver real value. We're going to start off with a presentation for about 45 minutes, and that'll be followed by a roundtable workshop, and then we'll come back towards the end with some outputs from the workshop and carry those forward. Our keynote speaker today is Ronan Collins. Ronan is Managing Director of InteliBuild and professional member and honorary treasurer of the Hong Kong Institute for Building Information Modelling. Ronan described himself as a virtual design and construction specialist. He's a structural engineer, a keen sailor, and does quite a bit of work for a charity and the Lighthouse Club in Hong Kong. Ronan has a rare combination of technical skills coupled with a firm grasp, very much a firm grasp on the commercial realities probably gained from the very competitive sector in Hong Kong, and exceptional interpersonal skills, like bringing that across to us. I met Ronan yesterday, and really his passion and enthusiasm and understanding of this whole sector comes across. I think what we're going to learn in the next 45 minutes is, the learnings from his knowledge in a very competitive marketplace, but also he's going to present some ideas that are really going to challenge our thinking on what BIM is and how we can get it into mainstream adoption. Ronan, over to you.
Thank you. Good morning, everybody. Thank you for coming in this morning. It's nice to meet so many people here. So this morning I don't have to speak slowly and I don't have to pronunciate my language very clearly, because hopefully you can all understand my dwindling Gaelic accent. So let me tell you a little story about how I ended up, first of all, in a place like Hong Kong. How many people here have been to Hong Kong or have been visiting Hong Kong? A handful. Hong Kong is, as you can see from the screen, an extremely dense, heavily built up environment. It is driven predominantly by government investment in infrastructure, and then secondly by the commercial sector. The banking industry, all of these buildings here in the banking industry, have been the forerunners of the building industry in terms of commercial development in Hong Kong. I went to Hong Kong in 2000, December 2000. I had a 2-year contract working for Arabs. Having done 3 or 4 years in Dublin, I said I'll do 2 years in Hong Kong, I'll do 2 years in Australia, and then I'll come back to Ireland and I'll enjoy life in Ireland. 12 and a half years later, I'm still in Hong Kong. I'm settled, I'm getting married, I've got my own business, and I'm doing quite well. So Hong Kong is actually a very, very exciting place and good fun to work in. But in Hong Kong, they build things on a grand scale. This is an image of a new cultural district that they're planning and going through with the construction of. In the foreground, you have a stadium which is nearly the same size as the Aviva Stadium here in Ireland. There's an accommodation block over an existing transport hub, and then you have an existing building which is the International Commerce Centre. That building is 102 stories tall. The top's out at about 500 metres. These buildings are all being designed in a traditional two-dimensional way. So to set the scene, not every building in Hong Kong is being driven through BIM. A number of key buildings are being designed in BIM, but not all of them are going through the BIM process. We're hoping to convince the authority to use BIM on this upcoming project. So this project is a 10-year development plan for this area of Hong Kong. To give you a sense of the scale of the industry, the red line along the bottom, these are 5 billion, 10 billion, 15 and 20 billion euros in terms of annual construction budgets. The red line is the government. So the Hong Kong government spends up to 10 billion euros per annum on infrastructure, hospitals, roads, ports, all that kind of stuff. And then the top line is the private plus government. So you can see the total construction. So in 1997, we had a peak when they built the new airport. It declined all the way into 2003. And since 2003, it's been climbing back up. And we expect another peak sometime in the next 2 or 3 years. So at the moment, there's a construction boom in Hong Kong. There's a large number of construction projects ongoing. And you can get a sense of the scale of the industry. So what I'm going to do is I'm going to share with you how we've ended up, where BIM started in Hong Kong, how we've ended up at an Institute of BIM, and some of the lessons we've learned along the way. So a project that will feature heavily in my presentation this morning is the Cathay Pacific Air Cargo Terminal. The Cathay Cargo Terminal was instigated by the client. So a key message from the presentation this morning is that this needs to be driven by the clients. The successful adoption of BIM has got to come from the client. It's got to be led either by the client's project management team, but definitely from the top to get the most success. So I'll talk more in detail about the Cathay Cargo job. This is another building which we worked on. It's called the Goodman Interlink project. It's a 1.2 million square foot logistics warehouse. So it's used to sort out cargo coming in from the container port and distribute it to airlines around the city to other ports. The client drove the BIM process. This was a little bit different. The client asked a company to provide an independent BIM model. So the design team continued to operate in a traditional two-dimensional way. So the architect did 2D drawings, the engineers did 2D drawings, and then an independent BIM model was created to check what was on those drawings. So it was effectively a coordination check. So in some projects we find the owner says the architect, the engineer, the contractor must drive the BIM. And on some projects we find that the owner says, okay, that's going to be too difficult. We'll do an independent model as a check on the design coordination. This is another example. This is a commercial development for a retail center. And again, this was a client-driven initiative. So the client had seen other successful developments and said, oh, I'd like to have that. So we have in Hong Kong what I call the Gucci handbag effect. So one developer gets one piece of software, for example, they work with a Gary technology platform, and one owner gets immense benefits. So the next owner says, well, I'm developing my new project, I want my Prada handbag. So they go and they use a Revit platform. And the next guy goes, no, I need to have a different handbag, so he ends up with another type of handbag. But the developers are all competing in the Hong Kong marketplace. They want to be seen to be leading the market, they want to be seen to be using innovative systems. So BIM is one of these innovative systems. So my BIM is better than your BIM kind of thing. But it's an interesting driver in the marketplace. But the big players are now coming into the BIM market. So the MTR is the Mass Transit Railway. And the MTR basically run all of the underground train systems in Hong Kong. They have, I think at the moment, something like 42 underground stations. And they're developing another 4 or 5 lines. The MTR have now started mandating BIM on their projects. Interestingly, they're mandating it to the contractors. So the designers are still working in 2 dimensions. So there's 2-dimensional architectural plans, 2-dimensional civil engineering drawings. But then the MTR comes to the main contractor and said, right, you, Mr. Contractor, must produce a BIM model from the 2D drawings. And you must tell us if there's a problem. So the models must be produced within a certain time frame, and the contractor must advise the MTR of any potential problems. They're basically telling the contractors, we know that there's issues in the 2D drawings. It's normal in the industry that we're going to have coordination problems. We know they're there. We know that the BIM system is a way of finding and resolving those problems. We're making you responsible. So don't come back to us in 2 years' time with a claim for delays and extensions and everything else because of a coordination issue. We're giving you the tools, we're giving you the mandate, now go and find the problems. Once they find the problems, the engineer then has a responsibility to fix the problem. So the engineer's responsibility has not changed, the contractor's responsibility has not changed, but the MTR as a client is saying we want to use the BIM system to identify coordination problems as quickly and as early as possible. So the main issue here is the MTR has written down who's responsible for generating the BIM, the time frames that the BIM has to be produced in, and what it actually means for the contractor and the engineer. The Hong Kong Airport Authority is also looking at BIM. But the Airport Authority have been lucky enough to have a little bit more time in their planning, and they have taken the initiative and they've said, for our new terminal, the design consultants will operate in BIM. So the Airport Authority, 2.5 years ago, signed a consultancy agreement with Mott MacDonald Arabs and ADAS Architects for the design of a new airport terminal, and they have to do everything inside of BIM. A couple of weeks ago, the contract for the construction was awarded. And in the contract for the construction, the Airport Authority have said to the contractor, the design consultants have produced a coordinated design model. So the Airport Authority have driven the consultants to produce a coordinated model. So in Hong Kong, the culture in Hong Kong is very simple. The engineers do a scheme design, the contractors start work as quickly as possible, and the M&E contractors do a lot of coordination on site. The Airport Authority have said, that doesn't work. So we want the E&M coordination done in the design. We're willing to pay for it. We want to use BIM. So they've driven a BIM process for MEP coordination. And then they've said to the contractor, we'll give you the model. Mr. Contractor, we're giving you the model. You must keep it up to date. So all of your subcontract information, all of your suppliers' information, all of your details from in manufacturing must be put into that BIM model. And at the end, you have to give the model back to the Airport Authority. So the Airport Authority will end up with an as-built 3D model of a new airport terminal. They've also said, for the purpose of maintaining and operating airfield, the contractor will use the models to demonstrate the buildability and construction sequences on the airfield. So one of the requirements in the specification is It's not just good enough to show us the pipes fitting in the building. We want to see the delivery of the materials. We want to know when you're going to close certain taxiways. We want to see where the cranes are going to be positioned. We want to understand the whole logistics using the BIM model. So in these examples, the owners, or semi-private owners, are telling the contractors or telling the architects what they want. And it's driving the industry. So it's not an architect coming along going, hey, we're going to do BIM. It's the industry going, we need to get it done across the board, and changing the whole thing. And the biggest mover in the industry is the Housing Authority. So the Housing Authority is led by a lady called Miss Ada Fung. And Miss Ada Fung is the first honorary member of the Hong Kong Institute of BIM, because she has solely driven the idea of BIM into the Housing Authority. In Hong Kong, we have 7 million people of a population, and of that population, about 1.8 to 2 million people live in public housing. And these are some typical examples of public housing blocks. The Housing Authority, on their website, have published their own BIM standards, their own user guides, their own guides for producing components, and their own systems for actually making the models. So the Housing Authority have made it public. We're going to use BIM on all of our projects by 2016. They've created the standards for people to follow, and they're driving the process. So now all the architectural firms, all the engineering firms, all the M&E firms, all the contractors are all starting to learn BIM, because they have to meet the requirements of the Housing Authority. So they're all trying to learn what BIM is about, how does it work. So we have all these major owners getting into the BIM in Hong Kong. So there's a change, a cultural change, a social change happening. But everybody starts asking the same questions. What is BIM? What does that actually mean? What does a client mean by BIM? How do we implement it? How do we actually make it work? And when do we start doing it? And who's going to manage this process? So myself and a number of my colleagues in Hong Kong have created and have built up an independent institute called the Institute of BIM. The institute is modelled on the same as the Architectural Institute. So we followed the Hong Kong Institute of Architects template in terms of membership structures, articles of association. It's a registered institute. And we actually have professional grades. So to become a professional member of the Hong Kong Institute of BIM, you have to have a degree in architecture, in engineering, professional qualification in construction, or some other professional qualification in the industry. And you have to have 3 to 5 years of experience using BIM in some way. And that allows you to call yourself a professional member. We interview all of the candidates in a panel interview. So each candidate who wants to become a professional member submits a paper and then goes through an interview process. It's been supported by the Housing Authority. It's been supported by the big agencies in Hong Kong so that the membership is recognized. So in some of their contracts, it stipulates the BIM project manager must be a professional member of the Hong Kong Institute of BIM. So there's a recognition process between what the owners want and then us actually recognizing people who are capable of doing the work. Our biggest step forward has been the production of a Hong Kong-based BIM project specification. And the BIM project specification is a template document. And if anybody here would like a copy of the document, we can circulate the document. It's publicly available. It's set up on our website that we capture your email address so we can keep you in the loop what's happening, but the actual system is available online. The project specification is divided into 3 key components. The first one is the planning of BIM. So there's a template, questionnaire template. You must go through 20 or 30 questions. What do you want to use BIM for? So we sit down with the owner, we sit down with the architect, we sit down with the engineer, and we say, right, on this project, we're doing this, we're doing this, we're not doing this, we're not doing quantities, we're not doing 4D. So we actually specify what we're going to use BIM for. So we come up with a plan. The second part is the process, and I'll show you some examples of the process. So we set out, are we going to do BIM through an architectural process? The architect uses a BIM software like ArchiCAD or Revit or some other system. The structural engineer does an authoring platform. The MEP guy does an authoring platform. Do we want to have a pure driven BIM? Or do we want traditional 2-dimensional documents and an independent checking process? So this system allows us to have either or. You can have a full-blown BIM, or you can start with the diet BIM, which is an independent model. And then the most important part of this document is creating the definition of a BIM project manager. So we're finding that it's all great having an architectural model, it's all great having an MEP model, somebody has to coordinate that process. So we've created this notion of a BIM project manager who's a professional in the industry. So I call myself a BIM project manager. I'm a chartered structural engineer, so I've got some knowledge of design, coordination, and construction. The responsibilities are very straightforward. Oh, it's time to wake up. Plan, develop and manage the BIM standard. Somebody has to control the BIM standard in a project. How files are named, how files are stored, how files are changed, how they're exchanged, how you find information inside the systems. There has to be a quality control and checking process. We find people are very innovative in the BIM environment. So they start creating all these wonderful models, but they get off track. So we have a quality control procedure to make sure they're actually following the right rules. Training is a fundamental component. The first mistake people make in the world of BIM is they don't invest time in training. These platforms are not out of the box, they're not Kellogg's out of the box platforms. You have to sit down and get trained to use these systems powerfully. So people who are starting off with BIM, the first thing you need to look at is, okay, you have to invest in the software, that's one thing, but you better have a good budget for training. Because if you don't train the staff, you're never going to get the value. Then this guy, the project manager, has to provide guidance to the project team on how to look at the models to resolve clashes, actually go through the process of coordination, organizing workshops, assisting them understanding design issues, and then providing technical support. Inevitably, there's going to be technical problems. So this is the role of a project manager. And this fits nicely into the idea that I've put forward in this paper, that there's three key issues in the technology or the implementation of BIM. The first is the people, and that's the most important. The second is the process, and the last is the power. I'm not going to talk about BIM software or hardware. It's been murdered to death numerous occasions by all the software vendors about how wonderful our technology is. What we have to focus on is the people and the process. And the people comes back to the training. So here's my take on the construction industry in Hong Kong and probably in Ireland. We operate in silos. So the architect has their domain, the structural engineer has their domain, and so on and so forth. For BIM to work, we need to collaborate. And I've taken two quotes. The first quote is from Charles Darwin, which is a very old quote, but this is actually in the 2012 UK BIM report. So they've done an analysis in the UK of the adoption of BIM, and this is on the last page of that report. Collaboration is key. In the Journal for BIM in the US, Turner Construction have said that collaborative project teams have the potential to lead the way in defining the standards for a cost-effective, predictable project delivery. The key benefit to BIM is knowing what it's going to cost and knowing when it's going to get delivered. That's the key underlining benefits of BIM. So you have Charles Darwin from the 1800s and Turner Construction from the 2000s talking about collaboration. So how does BIM enable collaboration? You first of all have to have a contract which enables collaboration. BIM will not work in a traditional risk litigation style contract. So if you're in a contract which is do the least amount of work and shed the maximum amount of risk, BIM is the wrong system. BIM is not going to create a collaboration environment. If the contract is written in some collaborative manner in terms of partnering, sharing, alliancing, IPD, whatever you want to call it, BIM will enable that process. But BIM will not create the process. So if you have an kind of an argumentative style agreement, BIM is not going to fix that problem. But if you have a collaboration style agreement, BIM can enable that process. So when we start doing BIM, we want the architect, the structee, and the electrical to collaborate. So we want them to build their own models, but then we want them to look at the models and start solving problems. So this is an example of a power plant or an energy plant. And it's showing simple things like a pipe clashing with a beam. This is stuff we see every day of the week, every job we work on. The next example is the camera flying around. Is a piece of ductwork hitting a column. Okay? In a collaboration style arrangement, these guys have to solve these problems. But what we're finding is they're not looking for the problems. So one guy is making a ductwork model, one guy's making a steel model, one guy's making an architecture model. I'm done. I've made my models, I'm finished. But who's actually looking at the coordination? Who's actually looking at the collaboration? So we have a very interesting lesson that we learned. This photograph in the corner is from the construction site for a casino in Macau called the City of Dreams. It's known in our office as the City of Nightmares. And the reason it's known as the City of Nightmares is the way the contract was set up. We were appointed by a design and construct contractor. So we were appointed by a company called Leighton China State Construction. And we were appointed as a BIM consultant to enable the design consultants to produce their drawings. So our job was to take sketches, markups, whatever you like, put them into the BIM authoring platform, and then generate the drawings for the consultants. So you had the situation where you had the designer, an external party, and then the drafting team for the same designer. You can imagine what happened. When these drawings were late, who do you think the architect blamed for the late delivery of the documents? It wasn't the designers. It was the poor donkey driving the BIM authoring software. So the experience that we had on this City of Dreams was we were trying to get involved as an independent company in the procedure of an architect generating drawings, because they couldn't get up to speed on the software. Oh, it's too difficult to learn, it's going to take too much time to figure out, it's never going to work. So the learning is never put a BIM consultant between an architect and his drawings. The architect has to learn the technology, and the architect has to produce his own drawings. And the same stands for the engineers and the MEP engineers. If you want to appoint a BIM consultant to enable them, let the BIM consultant do the training, let them provide technical support, let them second staff to the architect's office, and let them do planning for the actual BIM works, but do not let the BIM consultant be responsible for the production of the drawing, because the BIM consultant will go bankrupt, which is what nearly happened to us. So, you've got the people, now you have to figure out what we're going to put into the BIM model. In terms of change management, or in terms of process management, you have to rethink how you design and document a building. Okay, the days of getting a drawing rushed out on a Friday afternoon to meet a tender deadline is not the right way to work a BIM model. You cannot rapidly produce these 3D models. It takes time, it takes effort. So what we say is you have to define what is in this model. So we say you have to have a scope. You also have to define how people put the information into the model. So we look at these issues. Are we dealing with a design or a construction stage BIM? And they are very, very different. We can get away with murder on the design stage and then add in detail at the construction stage. So we tell consultants, work to a certain level of detail at the design and then hand it to the contractor who knows what he's doing for the construction stage. So again, in Hong Kong, the culture is very different. Scheme design, give it to the contractor, and the contractor works it out on site. Okay, so the level of detail changes as you go through the process. The BIM specification is utterly important. If you don't have a BIM, they're coining the term project execution plan. If you don't have a plan, you're dead from the start. So the first thing you have to draft is the plan for driving the BIM process. That will then get you through the clash analysis process. It will get you through the coordination and documentation process. It will even show you whether you're going to use it for production and fabrication drawings. And it will get all the way down to site installation. On the projects that we started doing 5 or 6 years ago, we didn't have these plans. And we paid the ultimate price. So when we started this project, the CITAEIN cargo terminal, give you a sense of scale, there's 2.6 million tons per annum going through this cargo terminal, or there will be next year when it opens. A cargo plane carries 110 tons of cargo. And here was the learning I had on this contract. Every time you go on your holidays, there's 20 tons of cargo on top of all your baggage in the plane. So every airline operator is moving cargo on every single aircraft. So this aircraft terminal will deal with 75 flights per day. So the aircraft terminal, the air cargo terminal, is designed for these numbers. Okay? It's not an architectural masterpiece. It's not a structural engineering phenomenon. It's designed to handle 75 flights per year. Same image as before. The client wrote 3 lines in the design specification. The design team must use BIM for the coordination of the air cargo terminal. Full stop. Please submit a BIM plan with your tender submission. Full stop. That was it. There was no specification, there was no project plan, there was no level of detail, there was nothing. 5 years ago. There was an aspiration from the client to use BIM. And they had no idea how to make it work. So the architect was appointed. And this is the generic shape of the building. The design team was made up and led by an engineering firm called Meinhardt, and they collaborated with ADAS architects, and they engaged us to support them in the BIM initiative. The architect did all their own BIM modeling with no help from external parties. So the architect went off and did all their own BIM modeling. And we had discussions about coordinate systems, origin points, naming conventions, and the architect, no, I'm doing it my way. do it my way. So the architect did it his way. What we learned was we should have had one of these. This is in the BIM project specification under the Hong Kong IBIM. We've now listed out pretty much every component that you have in a building, and we've identified what codes are needed in the model. Materials, type codes, size, and performance criteria. So now we sit down at the beginning of a project. Instead of the architect just, oh, I'm just doing it my way, we actually say, do we need all of these systems? And if we do, what level of detail are we going to go to? So we now have a whole menu of every building component that you need, and we identify whether we need to put it in the model or not. So on certain projects they're not relevant, on certain projects it's not important, but generally speaking we go through the process. The act of going through the process of determining what goes in the BIM model gets people thinking about how much coordination they have to do. When it comes to the structure, we had a bit more success with the structure. So the structure engineer had never done BIM before. The architect had done BIM on a previous project, so they knew what they were doing. It's fantastic. The structure engineer had never done it. So we were able to guide them about, we need to be able to take the steel and give it to the fabricator. So we were actually successfully able to model the steel at the design stage and then give it to the fabricator. It would have worked except for one cultural problem. The structure engineer refused to give his model to the contractor. And to this day I've never figured out exactly why he refused. But there was a perception that there was something wrong or there was some risk associated with giving the model to the contractor. So the contractor took the 2D drawings that this model was used to generate and remodeled into 3D in a different platform to do steel detailing. So the culture was, I'm not giving you my CAD files, I'm not giving you my Revit files. So now, based on the learning, in our project specification there's a line which says the structural engineer must hand over all of his Revit files or Tekla files, whatever it is, files, to the contractor. And all the engineers going, I don't want to do that. So the contractors in Hong Kong have said, look, we'll take them and we'll exempt you from any responsibility, any liability, any risk. And the engineers go, okay, fine, no problem. Because the contractors get more value from a model, even if it's not 100% correct, than from no model at all. But the engineers perceive that by issuing a CAD file, that if there's a geometry problem or there's a dimension problem, they're going to get their asses sued. So if you have an arrangement between the engineer and the contractor who says, look, you can have my model, but it's not my responsibility. And the contractor goes, give me the model and we're not going to come back after you. Then you have this relationship that works. So that was the issue with this one. In the structural framing model, we actually managed to label things. So we actually managed to label every element by its position in the building, its type, and its certain scale, so we could quantify the building. So we were able to tell the QS all the different quantities in the model. The QSs, excuse me, I'm going to get water for a second. That's better. The QS was another interesting cultural shock. The QS, we would give them a spreadsheet and say, right, here's all the concrete, here's all the steel. I'm not using those numbers. I said, what's wrong with these numbers? Oh, I don't trust the BIM model. So the QSs don't trust the information coming out of the BIM model. So again, at the beginning, if you're going to use the model for quantities, you need to sit down and get all parties to agree what information is required by the QS for their work. Because if you just do your BIM model and then email the QS a spreadsheet going, hey, look at this, I've got all this wonderful information out of the BIM model, QS is going to go, nah. And he's going to measure all your drawings. He's going to take out the 2D drawings and measure all the 2D drawings. So the culture is the QS doesn't trust the engineer to build the model correctly. So you have to get past that as well. And here's the fun part. This is the M&E component. This is the mechanical ventilation system. Smoke extract, staircase pressurization. We have come up with an E&M naming system. We have an electrical system. Again, we have a naming convention. And we get to a fire sprinkler system. In Hong Kong, the culture of the E&M consultants is fascinating. They will do the least amount of work possible to issue specifications to the contractors to do all the E&M coordination. In the US marketplace, the US contract has written that the E&M designer has to make everything fit in the building and the contractor doesn't install. The contractor in the US, all he has to do is install. In Hong Kong, they have to take scheme drawings and actually do all the coordination on site. So I'll show you some sequences from the slides that are on. So the consultants are working to a very, very high level or rough level of detail. So you have all these models. Then you have to figure out the roles of the people involved. So you have the culture of the silo. You have the architect, I'm doing my thing, structural engineer doing on my thing, and then you get this poor unfortunate BIM project manager who has all these models, and his job is to coordinate them. So you're looking for things like spatial arrangement. Can I walk into the plant room? Can I take the filter out of the ductwork? And can I replace a pump? The BIM consultants are looking for these problems. Not the architect, not the mechanical engineer, not the structural engineer, the BIM consultant, because they're thinking about the operation of the facility. How do I know that that is coordinated? How do we actually know? How does an architect stand up in front of his client saying, we've done BIM, everything's coordinated, it's sorted? How does that actually happen? Who's going to take responsibility for standing up and saying it's coordinated? So what we've done is we've developed a system of, we call it a clash detection matrix, and it's a hierarchical system. So if I get this to a pointer, there we go. So here you have operating requirements for a terminal. So the owner wants certain headrooms in certain areas for trucks and deliveries and everything else. The cargo operator wants certain requirements. So he's got some operational requirements. Then there's a structural requirement. Then there's an architectural requirement. Note the architect comes after the structural engineer. There's an architectural requirement. Oh, you are awake, good. And then finally the E&M component. We start off checking that the operational headrooms have not been compromised by the structural framing. We then get into, does the drainage compromise the headrooms? Does the HVAC affect the operation of the plant? And so on and so on. We eventually get down to checking if a piece of pipework is clashing with a piece of ductwork. To go through this process on this job took nearly 9 months. And it's an iterative process. So you think you have it cracked here, you go all the way down, all the way down, all the way down, you move some pipework and ductwork, and you run the analysis again, you find out you just caused another problem back here. You run the analysis, you run the analysis, you run the analysis. You do not want to be doing this in an ad hoc, bit-by-bit manner, which is what we started off doing. We quickly realized if you don't plan out this procedure, you're going to end up wasting thousands of hours just checking models randomly. So the learning from this was you have to create an analysis system. So we start creating these batch systems. So we start using the software to batch out and analyze this automatically. So we can take out fire sprinklers versus framing. We can do it by level. So we can check each individual level to make sure we're identifying the problems by level. So we can find all the problems. And we use a piece of software called Navisworks. And this is the interface. So we can find out where the pipes are clashing against the framing. Brilliant. We're sorted. We know where the problems are. We're done. And then you go, now we have another problem. We can find these problems and we can show them to a junior engineer, or we can show them to the guy making the BIM models. Can we get the senior engineer to actually sit down and deal with these problems? The first thing is senior engineer, I sit down with a machine. Senior engineer, we have to relocate these pipes. Well, where are those pipes? Where's that on a 2D drawing? So the first thing the engineer thinks of is a 2D drawing. Okay. So what we've done now is we start marking up 2D drawings. I don't have an example here. Oops. We start marking up the 2D drawings. I haven't got an example here. And then they start to realize what the problems were. But then we quickly realized that any manner of success, you have to take, this is an example of the building, you have to take them into the building and walk them around one by one. So this is just showing, this is very quick. This is showing the delivery of the cargo into the building. Just a little graphic, fill the time. The whole system is automated, so all the cargo is moving around these automatic rollers, and then it's going off to the planes. So from a BIM system, what we're doing is we're sitting down with the engineers, and we're walking them through the building. See if this works. Technology never works when you want it to. So the software will tell us where we have problems. So here we've got a clash between a camera and a duct. Here we have the warehouse area, so you can get a sense of the warehouse. And luckily this building has very high headroom, so the coordination was not that difficult in certain areas. But all of these models were all built by different contractors. This is the construction stage model. And they've started putting in some steelwork for maintenance access. And we suddenly realized that the steelwork for the access was causing a new coordination problem. The steelwork hangers were causing problems with ductwork. Now we can spend all day walking around these models showing people clashes, but that doesn't actually get them resolved. So you can find hangers clashing with pipes and everything else. What we discovered was the only way to get senior engineers to actually fix the problem is give them a drawing, put the numbers of all the clashes on the drawing in each location, and then give them a file with each number clash and a pretty picture. Simple JPEG, just print it out on a piece of paper. This duct is clashing with this concrete pit, and it's on that drawing in that location. It means that the BIM consultants are doing a lot of work to communicate the problem back to the designers. So what we're finding is that it's very good having all these 3D models. It's fantastic doing the clash analysis, but you have to put in a lot of work to be able to communicate where all the problems are to get them solved. So this is why we've got all these procedures that we have to go through. Now you can imagine the reaction when a BIM consultant, who the industry thinks is a software guy, turns up and starts telling mechanical engineers and structural engineers that the design doesn't work. The reaction is not very positive. So we've had to be very diplomatic in how we actually explain some of these problems to some of these very sensitive designers. So what we've done is we've actually created a system where for every single drawing we create this printout. So you have a two-dimensional drawing which the architect can relate to and the engineer can relate to, and a 3D snapshot saying this is what the problem looks like in 3D. And then we have to go through a workshop, and we're now running on one of our jobs a workshop twice a week. So on a Tuesday and a Thursday we get all the parties in a room and we spend the whole afternoon going through an area of the building, resolving clashes, resolving coordination issues, everything else. And it's set up in a very particular way. We say this is a collaboration discussion. You're not allowed to take minutes. You're not allowed to come back and sue my ass. All you have to do is sit down and work out these problems. But you have to do it collaboratively. So somebody's going to have to move a pipe, someone's going to have to move a bit of duct, someone's going to have to rearrange some wall panels, someone's going to have to lower some ceilings. But as a team, we have to collaborate and organize it. So our guys are orchestrating this collaborative style workshop. And then we can produce these reports. So we can actually produce reports which say, it's like getting a health check. The building is okay, or you've got a serious health problem, or you need to take some serious medicine. So we can actually give a report about how healthy your design is. But the collaboration and the management of that is very, very interesting. And the social interaction between the architect, the structural engineers, the contractors, and the BIM consultant is key to that success. So we've spoken about the designers at length. What about our friend, the contractors? So one of the issues we have is this cultural issue of I'm not giving my files to those guys. We live in an industry where it's those guys and us guys, or as I call it, trench warfare. These guys on this side of the trench don't want to give their files to the guys on the other side of the trench, and vice versa. So we're now brokering deals where the consultants have to issue their files, lock, stock and barrel, to the contractors. Once the contractors get them, they can use them for quantities. The contractors want to know what the quantities are, even if the QS doesn't. The contractors want to pull out all the quantities and get a sense of how much concrete, how much steel, how many meters of pipe, numbers of pumps, etc., etc. When we went to site, this is the CITAEIN cargo site on site. So this is the main cargo terminal, and you can see the airfield behind. We're on site. I got asked a question. Does the BIM model reflect what's happening on site? And I said, well, hang on. The BIM model is driving what's going on site. So the ductwork in the 3D model should be the same as the ductwork on site. So I asked the E&M site engineer to go out and take photographs and compare them to the 3D model. So here you can see an area of the operating warehouse. These are gypsum panels for smoke barriers. And for some reason that image is half the screen a little bit. That there is an opening, which is not a missing piece of gypsum. It's actually for a connecting piece of ductwork. So we were using the 3D model to generate the actual cut drawings or shop drawings for all these panels, and we were setting out the ductwork in 3D. This is an area of the building, which is very early on, but you can see the amount of servicing required going into the building. So the contractor started looking at site photographs and then looking at the 3D model. Oh my God, I've got to put this in, I've got to put this in, I've got to put this in. So it became a very useful tool for them to understand the construction. Here's another photograph of the construction site. And here you can see they've got a health and safety issue. They have a double height space and they have to install cable trays, sprinkler pipes and other sprinkler pipes here in a very high volume space. And you can get a sense of it here. The contractor quickly realized it was a safety issue. So they started thinking about, okay, how are we going to scaffold this up, how are we going to get access, etc., etc. This one just shows the level of detail. This is a different problem. This area here, this is a steelwork platform hanging from a concrete structure, and this clearance is 8 meters or 9 meters. So again, the installation of this steelwork became a headache in terms of the logistics of building the building. The BIM model that was created by the design team enabled the contractor to plan out their works much more successfully. The contractor was able to rely on the level of detail in the model to enable them to build the building. So they knew that the model was right, which then allowed them to build the building. This just shows the cable trays. So you can see all the different formats. Now here's the funny story. I got a phone call one afternoon. Ronan, the BIM model is wrong. It's completely rubbish. I said, why? He said, well, we've put in a ductwork and it's clashing with all the cable trays, it's blocking the sprinkler pipes, blah, 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 blah. I said, well, hang on a second. Can you send me a photograph? So I got this photo. This is not the actual photograph. I got a similar photograph. And tell me what grid lines you're looking at. So I get an email, grid line this, ductwork here. So I open the 3D model, get to the same point, and the ductwork in the 3D model is on the left-hand side of the columns, as it is here. And on the site photograph, the ductwork's on the right-hand side of the column. This ductwork's 2 meters wide and a half meter deep. And all this happened on the Saturday morning after a couple of pints. The surveyor has put the ductwork layout lines on the wrong side of the columns. The install team have gone in, put the ductwork in exactly as the lineouts, and the BIM model was wrong. So the culture is, the 3D model must be wrong. There can't be the guy on site didn't make a mistake. That never happened. But it took us a whole day to figure out what the actual problem was, and it came down to a guy with a hangover putting the line on the ground in the wrong place. They pulled down the ductwork, put it in the right place, end of problems. So the initial reaction, the initial kind of culture is blame the guy with the technology. He's got to have it wrong. Get him down here, get him down here, get him here, spend a few hours, get him to fix it. But the actual problem was the site problem. So you can see the ductwork lined up in the computer model, and you can see where they put it in the right place. The most interesting thing from this project was the contract project director, old school construction guy, was completely anti-BIM. Oh, this is bullshit, it's going to waste time, and all this fancy 3D model, da-da-da-da. He's now making use of it on other projects because he can see the benefit. So I asked him recently, I said, how much money did you save because of the BIM process? No idea. He said, how much money did you think you saved? No idea. I said, okay, how do I measure how much money we saved? You'd have to build 2 buildings, one with BIM, one without BIM. I said, we're not going to be doing 2 buildings, one with BIM, one without BIM. So after half an hour of discussing it, it came out, the 2 key issues, one was there was less coring on site. There was less actual reworking on site. Now, I don't know how you actually price that, but there's less reworking. But the one that I found fascinating was there wasn't a queue of contractors at my front door on a Monday morning. He was so used to, and this, everybody blaming everybody else's culture, that he would have 3 or 4 subcontractors standing at his front door on a Monday morning going, he's done this, and he hasn't done that, and I haven't got this, and I can't get this, and blah, 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 blah. He didn't have that problem. They all knew what they were building, they all knew where they were building, and they all got on with it. So that it's hard to put a dollar value against the BIM process in certain things, but when a contractor tells you it's valuable, and I'm using it on all my other contracts, there's something there. The same contractor uses BIM on nearly all their projects, regardless of whether the client wants BIM or not. And I actually suspect, and from what I know of this industry in Ireland, the contractors are taking to this faster than anybody else. And the contractors will start driving. So if the clients don't pick it up, the contractors surely will, because they're the ones that can save the money. A last bit of kind of inspiration for you, if you like. How am I doing for time, by the way? Yeah? This is in Finland. This is the VTT. It's a technology forum in Finland. They're now looking at design for safety in BIM. So what they're doing is, it's not just good enough to model the structure and model the architecture, model the MEP. They're now modeling formwork systems. So they're putting into the design model the formwork systems, and they're looking at the formwork installation. So they're actually looking at, in the design stage, this is not on site, this is during the design stage, where the formwork needs to be, where the handrails need to be, etc., etc., etc. And then in the actual BIM authoring software, they're modeling all the required handrails, all the required fixing points, and then putting them on the design drawing. So when they actually fabricate the steel, when they precast the concrete, all the fixings for the safety systems are pre-installed. So it's not a guy going around with a Hilti hammer gun, nailing stuff to the ground after the building's been put up. They're actually all pre-installed. So they can prefabricate the beams and the systems to quickly install safety systems. So the contractor's not just looking at BIM from a dollar point of view, they're actually looking from a safety point of view as well. And we've now got a contractor in Hong Kong thinking the same way. So they're looking at design for safety, putting in safety and everything else. And the reason I show this is I'm a big advocate of safety on site. I do a lot of work for the construction industry charity called the Lighthouse Club. And we're looking at ways of using BIM to leverage into this system. So hopefully this morning's scatterbrained presentation shows you the importance of getting the right people in the right roles, getting the right process in terms of how you build the models, the level of detail in the models, when you model to a certain level of detail, how you do the clash analysis, how you report the clashes, and then how you go through the coordination and the collaboration stuff. And I'll leave it up to the vendors and everybody else to tell you about the power that's required. If you are investing in BIM, my only advice is buy the most powerful, fastest computers you can find and invest in them and run them off over 2 years and replace them every 2 years, because the technology is fundamental in terms of performance. So hopefully you found that interesting, and I look forward to participating in the Q&A session. Thank you all very much.